Welcome to Smith's Interconnect 360 Connectivity Podcast. Join our experts as they explore high-end and cutting-edge topics that shape and influence the connectivity world. Enjoy this week's episode.
Welcome to Smith's Interconnect 360 Connectivity Podcast, the podcast that explores the connectivity trends and applications in today's manufacturing sector. I'm Mark Kennedy, Product Marketing Manager for Smith Interconnect, and I will be your host for today. In this episode, we'll be diving into discovering the history behind the Hypertac Contact Technology dating back to 1956. I have with me today Joydip Sanyal, Product Line Manager for Connectors. Joe, thanks for joining me today.
Thanks, Mark.
So let's get right into it. Today's Hyperboloid technology is well-known and widespread contact technology, widely used by many manufacturers, but probably not everybody knows its origins. Joy, what can you tell us about it?
Right. Thanks, Mark, for the question. So the original technology was, in fact, invented and then patented in 1956 by a pioneering French company, FRB, which later was known as or became known as Hypertac, and today as we know it as Smith's Interconnect. Let me give a bit of history about how this all kind of started panning out, if you like. So Francois Robert Bonhomme invented the Hyperboloid contact in 1956 in response to the need for more reliable connectors used in the railway applications. Now, you see, by that time, railway systems had lightings and ventilation. So we're talking about 1956, right? So if you put this in context of 2024, I think things did advance to lighting and ventilation. But due to the high amount of shock and vibration that occurred in the train cars, the connections were not reliable. So this resulted in frequent interruption of their services. Now, the connectors being used were simple stamped or machine contacts with a very small area of contact between the two halves of the contact technology, the pin and the socket. Now, the bright idea that Francois had was to create a contact with multiple connection points along the surface of the pin. So this was accomplished by creating a wire cage in a hyperboloid shape that was then wrapped around the pin when the connection was made. Now, what happened is that with this multiple point of contacts around the wire cage, as you can imagine, the connection remained continuous, even if some of the wires briefly lost contact due to the shock and vibration of the application. Now, development of the technology continued into France into the 1960s and was eventually patented and registered with the Hypertac trademark. The patent was offered to companies in other countries, expanding its use in new markets and applications impacted by similar attributes like shock and vibration, such as in applications like in military or aerospace. The high-speed signals increased the use of this sophisticated technology on fighting vehicles such as helicopters that needed to limit signal interruption to less than a microsecond and eventually less than a nanosecond. It's quite a demanding application. So in the face of all of this happening in the face of increasing vibration, now this led to the success of hyperboloid technology in markets like in defense, and then later on in many other applications. Yeah.
Oh, that's a lot of history right there.
Indeed.
Thank you. Yeah. So what is it that makes this technology so special and so widely applicable?
Yeah, that's a good question, Mark. So the unique topology you see uses a set of contact wires aligned hyperboloid in a hyperboloid shape, basically, to the axis of the inserted pins, forming a sleeve around the contact and then providing a large 360 contact surface. So you see, the hyperboloid contacts are extremely resilient under rough environmental conditions, and combined with low insertion and extraction force and low wear of the plating surfaces to provide high number of mating cycles that can go up to an amazingly 100,000 cycles. So the hyperboloid socket has a number of spring wires, the position of which is defined by a wire carrier. This is fitted to an outer sleeve or shank that carries the termination of the socket. The spring wires within the socket are set at a very small angle to the center line and are deflected when mating pin contact enters. So subsequently, each spring wire is deflected within its elastic limit and makes a line of contact with the pin. A smooth wiping action reduces the wear of the plating surfaces of the pin and the socket wires. This construction allows a very tight control of the spring forces, and hence you see the insertion and the withdrawal forces are very in comparison to other technologies, are quite small.
Okay. So to make it all possible, I guess we are talking about reducing dimensions and a greater variety of different connections to choose from. What can you tell us about that?
Yes, that's correct, Mark. Now, thanks to its exceptional versatility in terms of number of connections, pitch, and pin size, the Hypertac Contact offers pin dimension from as small as 0.3 millimeter diameter for, as you can imagine, for signal contacts, to as big as 27 millimeter for high current, and without limits for termination type. So the beauty of the technology is such that you can have it for crimp, solder cup, DIP straight, or for SMT applications as well, and pin finish or for coating. And without limits for termination type, for example, it's available in crimp, solder cup, DIP straight, or for SMT, and pin finish or coating. The contact itself is enclosed in a housing that can be easily mounted on a PCB, D-shape, rectangular rack and panel, circular, or customer defined, thanks to the company's long-term experience in manufacturing or of all the different connector types, from the insulator to the metallic frames, grommets, and any kind of docking system and cable clamps.
Okay. So are you saying that the success of the product relies solely on its winning technology?
You see, the core technology is crucial, but as always, there's more to it, right?
Yeah.
A product success cannot simply rely on the core technology in itself. So in this case, being it's a custom connector, there is a wide knowledge of materials, production tooling involved, and the ability to supply functional prototypes in a short time or to validate solution within a laboratory settings. However, the key factor is a close mutual relationship and confidence that we managed to foster between the supplier, being us, and the customer and the end user, I mean, starting from the first sales meeting and then gradually progressing in discussing more on the technical aspects and attributes of the application, the use of connectors, and how it can alleviate some of the problems around connectors. So Smiths Interconnect's steady growth confirms that the benefits of custom solutions and the use of high performance connector are also appreciated and by purchasing and procurement professionals who sometimes have the impression that a custom product, quote unquote custom product, if you like, can make them lose control over cost or exceed their budgets. Now, you see, the aim is therefore to move from a culture of considering only the unit cost that you pay for the first time to a cost of ownership model, like the total cost of ownership model, that allows designers to fully realize the benefit of Smith Interconnect's product while justifying a premium unit price commanded by such connectors. Because the high quality approach translates to enhanced end product reliability and performance, customers recognize that there is a positive impact. This comes not only in the form of lower ongoing cost, because often what happens, Mark, is that a piece in that calculation that doesn't get kind of captured is the what is the cost of not operating, or what is the cost of poorly operating with a poor quality connector, and the cost of maintenance and warranty repairs, but also in a very positive sense in terms of reduced qualification cost with no retesting due to contact failures, and enhanced corporate image that kind of comes all as part of it, really.
Yeah, that's very, very interesting, Joy. Yeah, I appreciate that. So what can you tell us more about the many applications this technology can be applied to? As you stated earlier, you mentioned the solution was born for the rail market and later applied to military and aerospace applications. Are there more applications?
Oh, absolutely. Means exactly to your point, really. As we said at the beginning, that this contact technology was first applied in the rail environment, rail applications. Now, of course, the technology has expanded into many different end-use applications, product offering, also covering applications in space, aerospace, medical, and industrial markets. But going back to the rail applications, you see connectivity can play a kind of crucial role in the train braking system. So when the train deaccelerates, that functions that implies passenger safety, environment, and the property of protection, if you like. With this in mind, the Smith Interconnect's designers paid great attention to reduce the overall maintenance cost, as well as to provide a dependable and market-aligned solution. Now, safety critical systems like this are often exposed to very high vibrations and extreme temperatures, not to mention that they are all operating in arduous environment. And therefore, you see, they need reliable and robust components to achieve the necessary performance, system qualification, and customer confidence. Now, one such example would be from the product portfolio that we have got is a C-series connectors. It's a family of EMC metallic circular connectors that was designed keeping in mind all the above mentioned requirements and preambles. The series features the Hypertac Hyperboloid contact in a IP67 circular connector with the EMC metal housing, suitable for automatic trains operating and traffic control, and in particular for sensors in train braking system as they resist under the most extreme environmental conditions that they are operating under.
Now, you mentioned earlier the medical market. Can you elaborate on that?
Yeah, of course. You see, in the medical applications is a valuable example of which we are genuinely very proud of, right? One of such success I can mention here is with the portable driver system for the total artificial hearts developed a few years back, which is the best showcased in the Hypergrip series featuring the Hyperboloid technology. specialized design and development of the interconnect systems, including color coding, sealing, keying, and simple meeting actions. Smith Interconnect's design engineers worked closely with the customers to create an interconnect system of cable assemblies and connectors for the Freedom Driver that could confidently deliver a complete reliable system for them.
That is actually pretty impressive, Joy, and that's a great achievement for us. There's been for sure, some impact for people in their life. I definitely think that is.
Absolutely.
Yeah. Do you have any other applications you can address?
Yeah, why don't we kind of mention also a little bit about the in terms of this in applications like in space. Again, our heritage and pedigree, we are genuinely very proud to have been part of many space missions with several different products that have been key in solving mission critical needs. In particular, I suppose I can mention the Mars Perseverance space mission, which is, I suppose, is well renowned. Everyone knows about it. For which Smith Interconnect provides the Mars Perseverance rover with high performance, rugged CPCI 2mm connectors, addressing NASA's need for a high reliability connector solution to meet the mechanical, electrical, and environmental performance requirement. Now, as you can imagine, right, for an environment like under which it's operating, rigorous testings were performed at the Jet Propulsion Laboratory for extreme environmental conditions, including thermal excursions, corrosive atmosphere, excessive shocks and vibration, contact engagement, separation cycle, and other key requirements that NASA had set at the beginning.
Yeah. Smith Interconnect has a long list of space mission critical applications and products, as the company has more than 60 years in heritage in this space market. Oh, this is some great stuff, Joe. I really appreciate your time. One last application worth mentioning. Do you think you have one you could discuss?
You see, the last one perhaps we can talk about is the Hypertac technology has given extensive good results in the industrial market, as well as with a vast number of success stories. An example to that end is the highly reliable test systems for factory automation. The common goal for all test and measurement equipment is to assess the efficacy of operational processes and aid manufacturers in monitoring and, if you like, enhancing the quality, safety, and productivity of their systems. Now, when you look into this, whether you are measuring force, temperature, pressure, you name it, right? Surface, flatness, speed, flow rates, or movement of each single component that is part of the testing device really needs to achieve the highest quality standards to perform in such a demanding application where you suppose that is the checkpoint at which the customer's systems are being checked to ensure the highest quality. As a result of strong collaboration between our engineering team, the product management team, the sales team, Smith Interconnect was able to provide a solution that met the requirements set by customers. Our cabled mini modular N-series connector fitted their panel mounting and cables and was able to support various signal and RF transmissions, and it genuinely transformed the end-use applications for better.
All right. I see we have a lot of success stories related to this technology, Joe, and I do appreciate your time today. In this episode, you have told us how the Hyperboloid contact technology was patented way back in France and has now become key in today's Smith Interconnect product offering, touching different applications. It's been designed to be used in harsh and demanding environments where high reliability and safety are critical, and how it ensures unreliable performance in terms of reliability, number of remaining cycles, low content force, and minimal content resistance. I think all this is great information, Joy, and I really do appreciate your time. And I thank you very much.
Thank you, Mark, for having me today.
That's all for this week's episode of Smith's Interconnect 360 Connectivity Podcast. We hope you enjoyed it and learned something new. If you have any questions or feedback, please feel free to reach out to us through the form in our podcast webpage. Stay tuned for the next episodes in which we'll explore more topics related to connectivity solutions. Thank you for listening and have a great day.